Hey guys, welcome back. So today we got a 2013 Hyundai Genesis Sedan, 3.6 liter, I think. Customer complaint is there's a multiple warning lights here. So the background of this vehicle, it came from another shop. They said they repair some rodent wiring damage. And after that, this multiple warning lights is on. And then one tech locate the vehicle, but he told me he cannot communicate with the scan tool. So right now we got our breakout box there, right? Our scan tool, and I hook up our scope there running. So first, what we can see on our wiring diagram is we got this DLC data link connector, pin 3 and 11, or pin 14 and 6. That's our CAN high and CAN low, right? We got power, 2 grounds at pin 4 and 5, right? Is it pin 4 and 5? Yeah. And then, yeah. So at least it's this is gonna be an interesting one, because unlike that Elantra, it was just a fuse, because we know that our VCI for our scan tool is not powering up. At least right now it's powering up. We can see in our breakout box that is showing power there. I don't know if you guys can see that. And we have ground there on the other side too, right? And it's reading at around 11. So what's going on with this is, let me try this again. So you plug in your VCI there, the OBD2, and it's just gonna keep searching for our VIN, but it won't. See, so it won't communicate. And on our scan tool, scope, we can see here. Let me just see here if it's both are connected. Channel A is not connected. Okay, so that's a good indication. My channel A is not connected. So that's the so let's double check this. I got my 2 ground there. 2 ground. And then beside that there's gonna be the CAN high, and the bottom part of that is the CAN low, right? So I think we're in the right. Let me try here, 11. Sometimes we put it in the wrong side. Okay, so I don't think so. This is a CAN high here, CAN low. And you can see here one data link is not connected, or communication line is not connected, and our red trace is like connected, but that's grounded, right? Yeah, so what we can do next is, we know that we cannot go to our scan tool. What I'm gonna do, I have my wiring diagram here. So this is the CAN high and CAN low for the CCAN. I know some of these models, they have the multi-purpose check. Where's the multi-purpose check? Multi-purpose check. It's not here. So we just have to locate that. Why? ESC smart module vacuum ECM TCM ECM injector box joint connector fuse relay How about this guy here? Joint connector, parking brake, instrument cluster, and that's it. Where's the multi-purpose check? Okay, you know what? I'm gonna open the hood. I think I don't know why it's not here, but it should be here. Am I blind? No, it's just joint connectors. Um, Let me find where we can go for a C-can, the easiest way without removing anything, just to see, right? Because currently our channel A is that's open circuit. So we're in the computer right now. I was blind. The multi-purpose check was in here, as you can see if I follow my mouse. So it's just hidden there. You can click that, and usually that's under the hood, and usually it's either in the fuse box, right? So we got different communication light in there. There's a CCP can and the C can. So we're interested in the C can, pin 9 and 17. Okay, so we connected our leads now, and there's multi-purpose check. Let's see our capture. So right now both our test leads are connected. That's good, but we can still see there's some activities there, but it's still shorted to ground, right? Oh, we don't see the 2.5 that we're expecting to 3.5. So I think this is our data packets, but it's shorted to ground. So our next move here is to locate a connector that's easy to access, and we'll divide it in half. So most likely this is the whole network, right? We got our data link here, right? And this is the guy here, data link AB. Where's the AB? Go. So here our data link. This connection from A to B here. What we can do is I'm gonna look for an access to make it half, or at least we can divide the system, and if our waveform checks out good, we're gonna focus on what we remove on that connector. So in this case too, it has a vacuum pump, right? I know some Hyundai vehicles, especially the Tucson's turbo, they're very prone with the vacuum pump issue. It will make the whole network go down. So I'm gonna look for this connector EE21, right? Or EE31, and what else? GH. CD. So because this joint connectors here, this is the maybe the good to disconnect the whole thing, because that's all connected, right? But this joint connectors in Honda is always hiding, right? It's so hard to access. So let me look in the wiring diagram which one is the easiest access to make this network in half, because that's gonna be our plan right now. Because I can see right now on our scope capture that looks like it's shorted to ground, right? And in here on our data link, that can high is open, so we still have to figure that out, but I'm not gonna worry that for now. I'm just gonna divide it in half and see if our waveform will looks good, and then we're gonna check that open on this can high here. Alright guys, so I locate a joint connector here, the easiest access, just few trims to be removed. So that's the JF can. I'm gonna show you where's that guy. So JF can will be this guy here. So if we're gonna remove that, scope still attached here. So if our scope capture will be better, so we know that this side of the circuit is good, right? So we're gonna focus whatever circuit is in this side here, right? Because we're disconnecting that. So let me disconnect that and let's play our scope capture, and then let's see. Okay, let me just remove this thing. Come on. Why? Okay. Let's remove. Let me turn on the ignition. Okay, so what we have right now is still the same. Let me change my leads. Let me remove that from the multi-purpose jack, because I noticed here on our breakout box last time when everything is plugged in, let me plug this guy in. Our can low was not, you see that? It's off, and our can high is just flashing. Now if I'm gonna remove that, this guy is always on and our can high is off. So let me take out those leads on the multi-purpose jack and let's see our can signal here on this joint connector. Okay, so instead of me removing those connections, I just hook up my other two channels, green and yellow. So what we're gonna do is probe the other side first, and the low side. Okay, let's go see our capture. Here's our capture. I know there's too much time there, right? Let me just open that up. Okay. You know what? Let me adjust this time first. Let's go 2 milliseconds. Okay, stop. So what do we have here? So on our green and yellow trace, that's gonna be our on the joint connector that I just removed. So we have a voltage there for 4.4, and on our yellow 4.3, right? Something is not right here. Okay. Um, let me put these two leads now to the other side, and let's see what our capture is. Okay, so that's the other side of that lead, and we can clearly see on our green and yellow is the same thing as the blue and red, right? They're reading the same. So JF can, that's, I guess that this is the guy here, and number 4 the other side, something going on still. So now I have to look for another joint connector. What I can do is I can go to this injector box. At least this is the end of this high circuit or the communication line, right? I guess we're gonna baseline our reading from here, because I think even though we remove that joint connector and trying to split in half, there's something going on. So we're gonna go further and look something here, which one that we can remove, right? I know I mentioned about the brake vacuum pump. I'm gonna locate that and see, and then let's see our multi-purpose check again and what will be the reading. And then yeah, so the only thing that we can do right now is unplugging stuff, but we're gonna do it systematically. At least, you know, we're not, because there's a lot of modules just to unplug everything, right? So we're trying to divide everything. So yeah, let me look something here that we can do, and then I think on the multi-purpose check I'm gonna remove that connection. I'm gonna put it on our injector box and see our communication there, and then we're gonna go all the way on this side. So I'm gonna look for a best connector that I can remove, and then we'll see. Okay, so I just removed our left front wheel because we got access another joint connector here, and I told you earlier I'm gonna do the injector box, but the layout of the connection or the pins is not the same as the wiring diagram, so I'm just gonna leave it like that. So and I wonder too is, because I didn't get any more information, if what wiring repair that they did and which section it is, right? Because maybe that's from the wiring repair they did. So I'm just removing the wheel liner right now. Okay. Oops, there's another one. Oh my goodness. Okay, so I hope we can access those guys. Oh man. see some connection here. I'm gonna remove one right now. I know you guys can see anything, but I'm removing one connector right now that I'm thinking that was a communication line, and my waveform is still the same. Yeah, my waveform is still the same. So now I'm gonna try to probe from here. Green and orange. So, green and orange there. I can see something on our waveform. So here's our waveform right now. Let me stop this. Wait. Come on. Okay. See what we have. So on our green trace, that's our can low or can high. So right now we're at 2.5. That's good, right? Our yellow trace, that's still at 4. That's not good. And our the one that I connected is still the same. It's still going on there. And we can see that our can high is moving up and down. There it went to ground. I wonder, and then it moves again, right? So I'm gonna plug that back in because that's not our connector. Okay. And then when I plug that back in, we can see our green trace went high again, right? So if we're gonna think on our wiring diagram, we remove this guy, EE31. That's this one here on the left front, our EE22. So when I unplug that, so there should be no connection on this side, and I get the 2.5 something on our green trace, right? So I don't think it's here because we still have shorted to ground, right? So we're gonna go back here. So that's an M can. We don't have to worry about M can. We need to worry about the C can. So next is we got the adaptive front lightning steering angle sensor, LDWS module, PADS module, and electric parking brake. Where's this guy? Component. That's at the subframe, rear subframe. This guy, no. Where's this connector? That's at the back. No, we're not doing that. That's too much work. I think I am this guy here. It's a FR21. FR21, that's on our headliner side, A pillar. So if we're gonna remove that, disconnect that, we're gonna eliminate whatever on this LDWS instrument cluster, steering angle adaptive front lighting, right? So because at least this one is all inside, and that's on our data link connector. Okay. So let's go to FR21. I think that's my easiest. MF21, that's gonna be on the passenger kick panel. I think the wires are all crowded there. I think FR21. Let's do FR21. Okay, FR21. Let's do this. Come on, man. Hi. Okay, let me remove that. So hard for one hand. Okay, so remove the A pillar, and this is our FR21. I'm gonna remove this connector, and I guess I can see something. Good communication. Okay, so our communication is good now on our data link. So this is our data link here, and as you can see, I know it's not that nice waveform, but we can see from 2.5 to 3 point almost 4, right? And our low side, that's what, 2.5 and 1.2. So that's good, and that's on our data link connector, right? So let me play that. And this guy, that's our from the multi-purpose check. So I wonder if I can communicate to this guy now. Let's see, because I just removed something, but I think we cannot communicate because that's because I removed the, what do you call that, the ECM part. So yeah, I think we can still communicate, but at least we know that when we remove that FR21, our communication here is good, right? So I don't think we have a problem with the open, because earlier I mentioned that our can high was open, right? Because on the scope it's not connected. But let's check our wiring diagram again. So what we did was we removed this connector FR21, right? That's the farthest end there, passenger side. Remove that, and our communication on this side here, from adaptive, SRS module, steering angle, instrument cluster, and to our data link, it's good, right? Where's that again? Sorry, to the data link FR21. Now if I'm gonna look for that male pin on this 14 and 13, we should have a problem on this side. So now we're gonna be focusing on this side here, this side of this circuit. So the pads module, electric parking brake, that's all going CD, so all going here, all the way here, this side here. Yeah, let me put the connection on that FR21, pin 14 and 5, I think 14 and 13. Where's this JRB component? No, oh, that's FR11. Okay, oh, that's on the headliner. Let's not do that. So FR21, 14 and 13. Okay, so right now I probe on our male side, this guy. So that's gonna be on our right side, all the components, right? 14 and 13. So right now 14, 13, and blue, that's 2.7, and red 4.7. So something is still shorted on this blue red line, right? So I guess what I'm gonna do next is look for that other component, right? And see if it's gonna get better, because we know that on this side of the circuit is good, right? So we don't have to worry about that. We're gonna worry whatever on this component here. And I forgot, I removed our JF can, right? This guy here. So let me plug that in, because we already, I guess that's why we're not getting anything here on our blue and red, because I unplugged this guy here. Let me plug that back in. Let's see if we're gonna get something. Okay, so we're getting something there, and it's the same thing. There's some still short to ground there, right? And our red is short to ground. Yeah, it's still short to ground. So let's play this and then put more time here, right? And then because earlier we did our multi-purpose check, so we removed this guy, right? We remove the JF can, the one on the footwell, and what we did, and there was still short something on this side here now, so that's gonna be CD. So here, but when we remove the FR21, everything is good. I think I have to look for this pads module. So that's gonna be, where is this? I think pads module, that's on the back side of the seat. Okay, let's go back side of the seat. Okay, I hope we can access this guy here, because when we remove our FR21, our communication lines on the data link is good, right? Now let me put you guys here. Let me just look for that module. Where's that guy? I think this red one, because I can see a red and orange. Okay, I think this is the pads module. Okay, let's unplug. Let's check our capture. Okay, our capture is still the same, shorted to ground, right? Yeah, there's nothing there. That's nothing. So I guess that's five and six. I don't know if that's the one that I removed. So eliminate that. Electric parking brake. And then it's gonna come out here. And our multi-purpose check. So FR21 is disconnected. So let's see. I'm gonna put our scope again to the multi-purpose check and see what we have. And I guess I'm gonna start unplugging TCM, ECM, smart cruise control. But this EE21, I haven't removed that yet. I think that's a good one too, because that's on the passenger side. Wheel liner. I think I will try to do that. Yeah. Okay, so let's play this again. I remove our passenger front wheel. So I can see now our vacuum pump. Our vacuum pump is here. Let's remove this guy. Okay. Let's see what we have there. Did it do something? No, it didn't do anything. Shorted to ground. Where's the other connector? Looks like this is a Sedan. Where's that big connector? Alright guys, so off the record, because what I always tell before that, I was trying to divide the circuit, right, and see who's the culprit, because when we check our CAN signals, something is shorted compared to the other one, right? And every time I remove FR31 connector, we know all the circuit or the CAN signal is working as normally, right? And when we try to check our CAN signal all the way going back here, all the way here, nothing happens. It's like shorted to ground, right? And I can even put here, I shorted to ground. I put some notes, but I was too focused on our CAN signal. I think my mistake was when we measure our CAN high and CAN low on the data link on the OBD2 port. If something was wrong, we cannot see any signal. Next step will be doing a resistance check. That was my mistake because I didn't check that. So I'm gonna show you. So right now I turn off everything, because when you do resistance check, turn off everything, right? As much as possible too, if you can remove the negative cable, right? But in this case I remove it because I don't have any battery now, because it's been prolonged ignition on. So test your meter, 0 ohms. Put your one lead to the CAN high and one lead to CAN low, and we get 115 or 120. So meaning we got another resistor that has open, right? Open wire and open resistor itself, right? Because on these models there's 3 resistors, one in the cluster, one on the ABS module, and one to the ECM or the computer engine computer. So that's why every time we unplug the FR31, which is that's part of this network, this cluster and whatever other module, our waveform looks better, right? So check the resistance value, because we know that something is wrong in this side. So I check resistance value on the multi-purpose check. So that's CAN high and CAN lows too. So we're gonna check that. So my connection is still there. And as you can see there, we get short 4.0 something. It should not be like that, right? That's 4 ohms or 5 ohms, right? 4 or 5 ohms. That's not good, because if we measure here 4 ohms, right? Either one of this side here is shorted and one of this side is shorted too, right? So what I did next is just to eliminate if we have resistance here on ESC module. If I'm gonna unplug FR21, that's gonna disconnect the whole system in this side, right? And for this side here, right? So if I'm gonna unplug FR31 and then unplug EE21, so if I'm gonna measure my resistance value at the multiple purpose check, I should get something on the ESC module, right? So I'm gonna do that right now. So remove connector FR31. So we eliminate the other side of the connector and EE21. Okay. Now we go back to our multi-purpose check. So we're measuring this side now to this side. So when that's connected, so we should be able to measure the ESC module now, right? So ESC module, and as you can see that 4.9 on the ESC module. Now what we're gonna do is, if I'm gonna unplug ESC module, so here's our ESC module, and that short is gone. So now we know that our ESC module is shorted on our resistance side, because if we unplug that and there's still a short, it means that it's in the harness, right? So if I'm gonna plug that back in, okay, that's 4.8. okay, so now we know ESC module is bringing the whole circuit down. That's one. Second is, we know we have 120, right, on our DLC. So 120 here. So if you have two resistors, let's say we have one cluster and one ECM, and the total should be 60 ohms. That's, at least your communication lines are intact, right? But we have three resistors, so I calculate that, at least 40. But if we unplug that ESC module, so I'm gonna unplug this, right? Connect our EE21, right? I should be able to measure the ECM, right? Or the computer, engine computer resistor. So we're gonna do that. So that's unplug. Put back our EE21 to measure the resistance on that. So EE21, this guy, and then measure the ECM. So now let's do that again. And now we have resistance, right? So for me, we got a problem with the module and the computer side. So now what I'm gonna do next is, I got a different module here all we need is another resistance value, right? We're gonna plug in one on the ECM just to see the if everything is plugged in, we can get a good value there at the DLC, right? And plug in on the ESC module. So we remove the connector, we probe wherever is the can high and can low with the 120 ohm resistor for the ESC or the ABS module and the ECM, and we'll measure again the value on the data link, and after that we're going to check our scope capture. So I got one here, but it's gonna be very hard because because the resistor is there. So I'm gonna look on the pin outs here so that I don't have to hold anything, and I'm gonna grab another module. I don't know if I can find anything. It has a 120, and we're gonna try to plug it in, and we'll see. Alright guys, so I managed to get another modules. This one, if you remember, I got some faulty what do you call that, AC module for the Ioniq 5. It was low way before. I used that module. I just used the resistor part. I have a cluster here. I just used the resistor part. I put in our ECM side, and this guy is going to the ABS module because we know the ABS module is shorted, and we think that our ECM right now is open. So we should expect a reading right now here on our can high can low around less than 60, I think. And what do we have here? So we got 38 ohms, which is a very good reading. At least we know that our wires are all intact. I plug in everything, right? So far we didn't see any open, which is a good thing too. So now we know that our communication line is intact. Let's turn on this vehicle and let's capture a waveform and see if we can find anything, right? We can find a good one. Can high, can low. And I think last time I said on the very first attempt on repairing this was, I said that it could be there's an open on that circuit on can high because we didn't have any connections, right? We don't have any connections, so I think it was just my port on my OBD2 or the breakout box. So now, we're gonna be just looking on the green channel. Let me just turn off this blue and red because we're just going straight to the data link, right? So before we go anything, so this is how it looks like last time, right? This one is during when I unplugged the FR21. As you can see there, we get some voltage reading there and data packets, but it's not great, right? And on our blue and red, this is where we got from the multi-purpose check. So as you can see there, we got the reading was just 0 volts. Yeah, that's 0 there, and our blue is 0, right? So now I'm just gonna turn that off, hit the play. Where's that guy? Play, and then we'll just do ignition on. Right. Okay, there's still warning lights there. And let's see our trace here and what we have. Why is it crooked, or it's not the reading at the same time? Something is still shorted because we should have a good communication now. Why is it like that? That's 4 volts. That's 4 volts. It's not better right now. Let me see my connections again. Okay guys, so our waveform still looks the same, this one, right? I wonder if it will affect the same thing, because we know that our module are downs, right? ECM and the ABS. But when we substitute with the new, not the new, like with the resistor for the ECM and ABS, where I'm at DLC right now, everything is all connected, and we're reading at 40 ohms, right? So at least I know now with this type of testing that there's no open circuit on the CAN network, right? On the C CAN, especially the C CAN high and low, because I can measure the 40 ohms. But for the waveform, I'm not really sure if that will affect, because we know that the ECM and the ABS is not talking. We just substitute with the resistor. I don't know if it will affect everything with the network here. Well, what I'm thinking is we should have the same reading when, what do you call that, when we unplug the FR21, when we were just reading the side of the cluster side, right? So, and what we can do too is I can just double check if we have short to power or short to ground here. Okay, I have 2 on the ground side. I have 2 k ohms there. Okay, on power 57. Okay, that's for the high, and for the low 1.8 for the ground, 2.k. So I don't think we have short to power on ground, but I don't know if my substitute resistance is enough, right? Because I just get that from another module. So yeah, what I'm just gonna do is I'm just gonna double check if it's really open on the ECM. Well, I know the ECM is really open on that resistance because I measured the ECM itself. The ABS module, I have to do that. And with this testing, I think I would recommend a new ECM on this one and a new ABS module. I don't know how it got like happened like that, 2 modules at one time, or was it like that before when they had this car and they're trying to fix it? I don't know, so I have to tell this to the advisor right now. But at least what I know right now is our CAN high and CAN low is not shorted to ground and power, and our CAN high and CAN low right now is not shorted to each other, and all the wires are intact, right? But I'm still, doubting, because we should get the same waveform when we unplug the FR21 when we're just checking the cluster side, but we're getting this waveform. So I guess it's because too that we added more resistance value now, right? Because last time it's just 120 and we have this type of waveform. Or what I can do is I'm gonna separate each module and maybe see the other modules are talking or not, right? Or they're trying to talk or something, just to see that waveform, because maybe my waveform is like this because right now we have 40 ohms, right, compared to 120. So that's what I'm gonna do next before I pull the trigger to get a new ECM and ABS module. Okay guys, so I think the resistance will get factor on how our waveform looks like, because we got 40 ohms there on total resistance for the 3 resistors. So now what I did, just to check if there's activity going on, so in our wiring diagram here, I remove this connection here, GAC, right? So I'm eliminating the whole side of this part of the circuit, right? So I'm measuring right now the blue and red. Let's stop this guy. Blue and red, that's gonna be our can high, can low. So we can see that we got some data packets there, which is a good thing. And it's the same reading when what I did was, so that's disconnected, right? Now if I plug in the FR21 for the cluster, the whole thing will start wonky. So right now this guy are our green and yellow, that's for our cluster. Alright, it's communicating, no problem. There's like data lines or data packets, right? So what I did next is just to see if these guys are communicating or there's some data packets. Instead of measuring these 2 and 6 here, what I did was measure 4 and 8. So what happened there is I'm measuring whatever module on this side. I got the same packet, data packet, so I think that's it. At least now I know what's going on this vehicle. Of course, before replacing the module, just double check your power and grounds for that module. And then, yeah, so I'm just gonna double check the resistance itself on the module for the ABS, because I know on the ECM side is open. And I'm just gonna check power and ground for our ABS and the ECM. And after that, if everything checks out, I'm gonna recommend a new ABS module and ECM.